All right, I'm going to give you a quick lesson about average atomic mass and percent abundance. Okay, and so average atomic mass, when we're talking about that, it takes into account both the number of isotopes and their natural abundance. So there you have, we got a dancing bun, we have abundance. But really what it's looking at is, okay, out in nature, what percent are this mass compared to, the percentage of the other masses. And so I'm going to give you an analogy to start out. So let's say I want to know the average age of a student in the classroom. So let's say that I gave you no information, but I told you, okay, some of you in the class are 14 years old, some are 15, and some are 16. Okay, well, if I asked what do you suppose the average age is, you'd probably guess the average age is probably about 15, which, given the information I gave you, that's as good as you can get. So that would be a decent guess. All right. But let's say I give you another little piece of information. Let's say not only do I tell you the ages, but let's say I give you kind of a breakdown. All right. And so let's say I'm going to tell you there's a total of 20 students in the room. And not only do I tell you the total number of students, but I say, okay, there's only one 14-year-old. There happen to be 6 15-year-olds. And there are 13 of you who are 16. Well, that's going to change our average a little bit because now it's going to be skewed towards this end because there's a lot more 16-year-olds. The way you would do this is you would take their individual ages times their relative abundance, their percent of them. Okay, so what I would do, so the 14-year-olds, and there's only one of them, well, one out of 20, that's 5%. You take 1 divided by 20 times 100. So that's 5%, which is going to be, when you multiply it, it's going to be 0.05. Okay. Let's see. And then the 15-year-olds, there are 6 of you. Okay, so 15. And then 6 divided by 20 times 100, that's 30%. And so when you multiply percent, you have to move the decimal over 2 places to the left. It's going to be 0.30. And then the 16-year-olds, we said there was 13 of you. 13 divided by 20 times 100 is 65%, so that's going to give me 0.65. And when I do the math, I'm going to take 14 times 0.05 plus 15 times 0.3 plus 16 times 0.65. And when you do so, it's going to spit out this 15.6 years old is going to be the average age of a student in the room. And now look at that. Does the number 1, does it fit within the range? Is it between 15 and 16? Yep. And does it make number sense? Meaning, if you look at this 15.6, it's going to be closest to 16, right? And it should, because there are the greatest number of 16-year-olds. So, yeah, that answer makes number sense. All right. Looking at the next part here, we're going to do the exact same thing, except we're not using students. We're using different elements in their abundance of these different isotopes. So same thing, but all you have to do is you're going to take the mass of the first isotope times its percent abundance plus the mass of the second times its percent abundance, yada, 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 as many as you need to do, and that's going to give you the average mass. Okay, so it's really not that bad. Pretty straightforward. Okay, so what I'm going to do is I'm going to take this and I'm going to say, okay, the first one, we have 63, and its abundance, 0.6915. So remember, it has to be decimals, not percentages. To the next one, we said the mass is 65 times its percent, which is 0.3085. That's an 8. Okay, multiply, and then sum them. When you do so, you're going to find the average, 63.62, and we're going to label this AMU, atomic mass units. Okay, and does that answer make sense? Yep, it's between the range and it's closer to 63, and it should be because, nearly 70% of them have a mass of 63, so that looks like a valid answer. Okay, let's do this one. Let's say silicon. This time we have 3. No big deal. We just do it 3 times instead of 2. If I give you like a name like this and then a specific mass, use the most specific answer. Okay, so I'm going to take, let's see, 29.97 times its percent, which is 0.9223. Okay, the second one, 28.98 times its percent, which is going to be 0.0467. Okay, remember you have to move the decimal over twice. If you just do 0.4, that's multiplying by 40. That is not the same thing as 4%. Last one we have is 29.97 times its percent. Once again, two places, so 0.0310. Okay, I'm going to multiply, and sum. And when I do so, I'm going to get this. I'm going to get 28.08 AMU average. Once again, does that number make sense? Yeah, because 92% of them are, weigh 28, so it's going to be pretty close to that end. So once again, probably a valid answer. Okay, this one's different. Okay, this one I give you the average mass, and we're looking for the percents. Believe it or not, guys, it's the exact same formula. Okay, so you're going to take the mass of the first isotope times its percent abundance, plus the mass of the second isotope times its percent abundance, and this is going to give us our average mass. The only difference is now we know the average. Okay, so I'm going to give you a hint. When doing this, the initial mass, the mass of the first one, I always use the heavier one. All right, it's just going to make it easier. If you do it with the lighter one, you can still do it. You just end up with a bunch of negative numbers. And I find that people usually like having positive numbers, so I use the heavier one as the mass of the first isotope. Okay, we don't know its abundance, so we're going to call it X. All right, and to this, we're going to sum it times the, let's see, we got mass of the second isotope, which is going to be 35. Now, you could, I guess, potentially call this guy Y, but I'm going to give you a hint. If you start putting a couple of variables in there, you're going to have to use the quadratic formula in order to solve it. Okay, there's actually a much easier way to do this because we know something. All right, and just this only works if you only have two different isotopes. These are the only ones we'll do have two, so this will always work the way we're doing it. Okay, the thing we know about these percentages is that these two things are going to sum up to 100%. So we have that kind of advantage. We know that those two numbers sum up to be 100. So if this one is X percent, whatever that number is, this is going to be, you're going to take 100 and subtract what this guy is, and that's what's left. That's the remainder over here. How do we represent 100%? As a decimal number? Well, you move the decimal over two places to the left. It's 1. So what we're going to do is this. We're going to say there's our 100%. We represent that as 1 minus whatever this one is. Okay, so minus X. So these two now will sum up to 100%. If this is 40, this is 60. If this is 70, this is 30. This is 50, this is 50. Okay, that's the nice part about it. So with 2, you can call it X, and 1 minus X. And this is going to give us our average, which is 35.45. Okay, now all I have to do is distribute and solve this guy. 37 times X is 37X. Okay, 35 times 1 is 35. 35 times negative X should be negative 35X. And that's going to give our average 35.45. Now what I have to do is combine like terms. If I take 37X minus 35X, that should be 2X. If I subtract 35 from both sides, this is going to give me 0.45. Okay, now all I need to do is I am going to take this and I need to divide by 2 for both sides. So I do that. I end up with X equals 0.225. That X is the percent of the heavier one. Okay, so to make that thing a percent, all I have to do is multiply it by 100, or essentially I'm moving the decimal 2 places to the right. And so in this instance, I know that chlorine 37 has an abundance of 22.5%. Okay, I'm going to do the exact same thing now. Well, or all I have to do, since this is 22.5, I subtract that from 100, and that's going to tell me the abundance of chlorine 35. So if I take 22.5 and subtract that from 100%, that tells me that 77.5 are chlorine 35. Do these numbers make sense? Yeah, because if you look at it, if most of them are chlorine 35, the average is going to be closest to 35. So, once again, our answer makes good number sense. I'm going to do another one here real quick. Let's say I have neon. I want to find two isotopes of neon and their abundance. So same thing. I'm going to take the mass of the heavier one, which is going to be 21.99 times its abundance, which we do not know. I'm going to call it X. To this, I'm going to sum the mass of the lighter isotope times its abundance, which is 1 minus X, just like before. And then that's going to give us our average, which said it was 20.18 AMU. Okay, now I'm going to distribute 21.99X plus 1999 minus 1999X is 20.18. Combine like terms. This is going to end up being 2X. And if I subtract 1999 from both sides, this is 0.19. If I divide both sides by 2, X is going to give me 0.095. And so that is, once again, this is the percent of this guy. And so neon 22, and if I move the decimal over 2 places to the right, it's going to be 9.5% neon 22. That tells me neon 20, if I take 100 minus 9.5, that's going to give me 90.5% is neon 20. Does this answer make number sense? Yep, because if you look at it, almost 91% are neon 20. Yeah, that number is going to be really close to 20. I'm going to do one last one. Mr. Acker discovered a new element, Millard-Westium. 2 known isotopes, there they are. The average atomic mass is this. What's their percent abundance? So, let's see. We're going to take the heavier of the two, 308, and call it X. To this, we're going to add the second one, which we said is 303, and 100% minus whatever the first percent is going to give us our average of 306.75. I'm going to distribute 308X plus 303 minus 303X is 306.75. Combine like terms. This is 5X. If I subtract 303, this is going to be 3.75. Okay, now what I need to do is I need to divide both sides by 5, and that's going to give me X is 0.75. Okay, that's telling me the percent of this guy. So Millard-Westium 308, looks like 75% of them are that. That tells me Millard-Westium 303 is the remainder, so 100 minus 75 is 25%. And it makes number sense. Because if you look at it, if the average is 306, it's much closer to 308. There should be more 308s. Yeah. All right, well, we'll practice some more, but that'll give you just enough to get started.